Today I'm going to talk about the 7th grade geometric activity that I created using Polypad. So the task that we're going to be investigating today is that we're going to use 3 linkages at a time, which combinations do not create a triangle. And just a reminder that each of the linkages has an end that must be connected to another end to have a triangle. So the tool we're going to be using to do this is called Polypad. And it looks like this. And we have our linkages over here. And so as students explore, they're going to be able to start constructing some triangles by you place the linkage, you can rotate it, and then construct your triangles. So students will start to begin to see how they can construct this triangle. And then we also hope that they start to recognize what are the conditions that do not form a triangle. For instance, here, since the 2 shorter sides can't connect together, we cannot form a triangle. And so therefore, this is a case where a triangle does not exist. And so through the activity, we're hoping students start to make some generalizations and recognize the conditions that create triangles. So with that in mind, we have many geometric habits of mind at play here. So the main activity investigating invariance. Students need to be able to recognize when a pattern does exist and when it doesn't exist. In this case, it doesn't exist when 2 shorter sides added together are not greater than the longest side. And so they should start to make those recognizations. And by doing that investigation, they are also generalizing about geometric properties. So they're able to see the relationship of the side lengths and how they do or do not construct triangles. And then finally, we also want them to start recognizing when conditions exist that do and do not create triangles. That allows them to create conjectures and be able to summarize their findings and apply it to unique situations. So this activity, in my opinion, addresses 3 big ideas that show up in middle school. The first one being that behind every measurement formula lies a geometric result. Even though they don't necessarily generate a formula, they do create a rule, which is that the short side plus the other short side has to be greater than the longest side, or the sum of the 2 shorter sides has to be greater than the longest side. And so they begin to derive that just using the linkages. The second big idea, geometric thinking, that involves developing, attending to, and learning how to work with imagery. Students are designing their own triangles. They're using what they know about side lengths to think about how the side lengths interact with each other. And then they develop these complete models using the linkages. And then finally, a big idea 3, classifying, naming, defining, positioning, and conjecturing, and justifying our correspondent activities. They definitely engage in all of these as they are constructing their triangles, as they start to create rules about what creates a triangle and what's a non-triangle. And then eventually their conjecture is about the relationship of the side lengths so that they can justify how that they know any given side lengths create or does not create a triangle. So what I think is most valuable in this activity, and why I think it's good in the classroom, is that it gives visual parameters that help students investigate pretty quickly. And so by having just these linkages here, they can come up with some really deep understandings. And it's pretty accessible to most students. Most students can construct a triangle by 7th grade, knowing that there's 3 sides. And so by just using the tools here, by clicking and dropping and dragging and rotating, they're able to recognize some of those unique patterns that they may not have been able to do if they were just trying to construct via drawing.